Hello students, this is Physics by Gaurav. In this video, we'll be trying to understand the Faraday's laws of electromagnetic induction. You might or you must have heard the name of Michael Faraday. He was a great scientist, an inspiration for all of us. Rising from such a low level, such a very bad condition and poor condition, rising to become one of the greatest scientists of all time. So about Michael Faraday, I can say that he was behind the electricity, the mainly the AC generator, or the motor and generator, the electromagnetic induction. These were actually given by Michael Faraday. Okay. So in detail we'll discuss in some other video, but here we'll just try to understand the Faraday's laws of electromagnetic induction. Now, Faraday's laws of electromagnetism consists of two parts: Faraday's first law of electromagnetic induction and Faraday's second law of electromagnetic induction. Now first we'll come to Faraday's first law of electromagnetic induction. Now what does it state? That Faraday's first law of electromagnetic induction states that whenever a conductor is placed in a varying magnetic field, an electromagnetic force is induced. If the conductor circuit is closed, a current is induced, which is called induced current. Now, what does it mean that Faraday's first law of electromagnetic induction states that whenever a conductor, what is a conductor? It is a substance that can conduct electricity or that allows electricity to pass through it. So conductor, we can take example of a wire that is made of copper or some other material that is that allows current to pass through it. Okay. So when that conductor is placed in a varying magnetic field, that means, what do we mean by varying magnetic field? Is that magnetic field is changing. Varying magnetic field means magnetic field is changing. Okay. Then an electromotive force is induced in that conductor. So electromagnetic force is electromotive force. Sorry, I'm sorry. It's not electromagnetic force. It's electromotive force is induced. Electromagnetic force, that's a different force. Now this electromotive force is induced. Now what is electromotive force? You can simply consider it as voltage, but it's different from voltage. Voltage also, there is like terminal voltage and electromotive force. They are two a bit similar and a bit different also. There are differences between them, I'll make you understand in the next video. So here you just consider that whenever a conductor is placed in a varying magnetic field, an electromotive force is induced in that conductor. Okay. Now if the conductor circuit is closed, a current is induced, which is called induced current. Now one condition is there, that conductor circuit should be closed, because if it is closed, then only the current will flow through it. If the conductor circuit is broken at some point, then the current circuit is incomplete and the current cannot flow through it. So for this for the Faraday law, first law of electromagnetism to come into application, the circuit wire must be closed. So now you must have understood Faraday's first law of electromagnetic induction. Now here we'll try to understand through one diagram. Now in this diagram, it is a wire. It is a wire made of copper, aluminium or some other suitable material that is that can conduct electricity. Now this part is the coil. Okay. Now this is the full circuit, a closed circuit, and this is an ammeter. An ammeter is an instrument that is used to detect current. That means if a current flows through this wire, it will be detected through it. Now this is a bar magnet. You must be knowing what is a bar magnet. Generally in your childhood you must be playing with a bar magnet. It's just a magnet. It's just a piece of small magnet. Okay. Now we know that with a magnet, magnetic field lines are associated with it. That means either the magnetic field lines are coming out from it or the magnetic field lines are going into it. Okay. Now suppose the magnetic field lines through it, it is like this. Okay. Suppose it is like this. It is somewhat like this. Like this. Okay. Now if this magnetic field lines, what are these? These are magnetic field lines. Okay. These are nothing but magnetic field lines. So now if these magnetic field lines will if we know that these magnetic field lines will pass through this coil, okay. Now when these magnetic field lines will pass through the coil, it will not, the current will not be induced, or electromotive force will not be induced. But if the bar magnet is moved either towards the coil or away from the coil, then magnetic field lines passing through the coil will change. That you can easily understand from common sense, that if the bar magnet or the magnet is moved either towards the coil or away from the coil, then what will happen? Electromotive force will be induced. Why? Because the number of magnetic field lines associated or with the coil or passing through the coil changes. That's why an electromotive force associated with the coil is induced, okay, and a current is moving through the conductor, okay. Now I think so you must have understood the Faraday's first law of electromagnetic induction. Now we'll come to Faraday's second law of electromagnetic induction. Now first we'll try to understand the definition. Faraday's second law of electromagnetic induction states that the induced EMF in a coil is equal to the rate of change of flux linkage, okay. Now what is flux? First we'll try to understand flux. Below to I will make you understand in a detailed manner. Flux, here you just understand magnetic flux is nothing but amount of magnetic field lines or magnetic field associated with a coil or with a particular area, okay. So Faraday's second law of electromagnetic induction states that the induced EMF in a coil is equal to the rate of change of flux linkage. That means flux linkage, that means we know here, like we saw that the magnetic field lines associated with the coil was changing. That means magnetic flux associated with the coil was changing, okay. Now the rate of change of flux linkage is what? Rate of change of flux linkage is, that means change of flux per unit time, okay. So we know that from the Faraday's second law of electromagnetic magnetic induction states that the induced EMF in a coil, that means the EMF which will be induced in this coil, is equal to the rate of change of flux linkage. Then we know that when a bar magnet or magnetic field lines associated with the coil is changed, an EMF is induced in the coil and a current moves through it. But that EMF induced in a coil, it will be equal to the rate of change of flux linkage. Means suppose flux has to change, magnetic flux has to change, magnetic field has to change, so that an EMF can be induced. But at what the rate is that flux changing or magnetic field lines is changing? That means the formula for this induced EMF is minus n delta phi by delta t. Now this E is nothing but the electromotive force. This delta phi, this phi is nothing but the magnetic flux, and N, capital N, is the number of turns of that coil. Now the electromotive force, every time I am confusing it with electromagnetic force, do not do this mistake, it's electromotive force. So this electromotive force is equal to minus of N delta phi by delta t. This delta phi by delta t is the change in flux per unit time. That means the rate of change of flux, okay, and N is the number of turns. So we get the formula of electromotive force, that is EMF. EMF full form is electromotive force. So the EMF is equal to minus N delta phi by delta t. Now there is a reason for this minus that I'll make you understand in the some other video, okay. But for right now you just understand E is equal to minus N delta phi by delta t. Now here we have understood the Faraday's first law of electromagnetic induction, Faraday's second law of electromagnetic induction. So we have finally understood the Faraday's laws of electromagnetic induction. Now in these definitions we used magnetic flux. Now here we'll try to understand, I'll try to make you understand what magnetic flux is in detail. Now first we'll go through the definition. Magnetic flux is defined as the number of magnetic field lines passing through a given closed surface. That's what I said you earlier, okay. Magnetic flux is nothing but it is the number of magnetic field lines passing through a given closed surface, okay. It is denoted by phi or phi b. B denotes the magnetic field. Its SI unit is Weber or WB, okay. So magnetic flux is nothing but the number of magnetic field lines passing through a given closed surface, okay. No, the formula for magnetic flux is given by phi b is equal to b dot a. Dot means this is the dot product. B is nothing but the magnetic field. A is nothing but area. So b dot a, we know that a dot b is equal to ab cos theta. So here b dot a will be ba cos theta. So b is the magnetic field and a is the area. So if we want to find the magnetic flux, then what we have to get first we need to get the magnetic field, then we need to get the area, then we need to do the dot product between them. So b dot a will be ba cos theta, where b is the magnetic field, a is the area. So phi b will be ba cos theta, or the magnetic flux is found by the formula ba cos theta. Now suppose that let us understand magnetic flux through a diagram. Suppose there is a particular area of A. Okay, suppose this is a irregular area of area A. Now this is magnetic field lines in particular direction, which is denoted by B. Now let us consider that the direction of the magnetic field is at an angle theta with the plane surface, of that area. Okay, now this angle between the magnetic field and the area is theta. So this cos theta, in this cos theta, the theta is nothing but the angle between the magnetic field and area. So from the diagram we can understand that magnetic field lines is at a angle theta with the surface of the area A, or the plane surface area A. So phi b will be equal to b dot A is equal to ba cos theta. So where b is the magnetic field, A is the area. So I think so you must have understood the magnetic flux, the Faraday's laws of electromagnetic induction, which is the Faraday's first law of electromagnetic induction, and the Faraday's second law of electromagnetic induction, and magnetic flux also you might have understood. I think so this video must be quite helpful for you, and I'll be taking some more videos in the future, so that you can understand physics in a much better way. Okay, so this is it for today, and if you like the video, then do share, subscribe, comment. Okay, you can share with your friends, and you can share with your friends, family members who want to learn physics. Okay, so that was it for today. I hope I'll see you in the next video. Thank you so much.